So with this experiment, we will be mixing salt and pepper together on a plate, and then I'll take a balloon and rub it against my head and then hold it over to the plate and see what happens. So the material that I'll be using is salt, pepper, and a balloon. So what I'm going to do now is pour the salt and pepper on the plate and then mix them together. Okay, now I'll rub the balloon on my head. Okay. So none of the salt or pepper stuck to the balloon, but it is very humid where I am at right now, and we've been having a lot of storms, and we're actually in the middle of a storm right now, so that is probably the main reason why the pepper didn't stick to the balloon. But I tried it earlier today, and some of them did stick, some of the pepper did stick to the balloon. And so my hypothesis at that time was that a mixture of salt and pepper can be separated by making use of physical properties such as weight and electrical charge. And then the salt and pepper acted differently because salt is small and rough and crystallized solid, whereas the pepper is a flat and light solid. My first observation is that is what happens to the salt. My second is what happens to the pepper. My second observation is what happens to the pepper, and my third was what happens to static electricity. Static electricity occurs when two materials such as hair and plastic are rubbed together or repeatedly put together and separated. This movement rips apart electrons off of one material and moves them onto another. This creates an electric charge in both materials, and one receives extra electrons and becomes negatively charged, whereas the other loses electrons and is then positively charged. Opposing electric charges, so a positive and a negative, attract each other, whereas identical charges, so like a negative and a negative or a positive and a positive, repel each other. And when you put an electrically charged rubber balloon next to another material, such as like the salt and the pepper, or my hair, the other becomes electrically polarized, and the electrons moved accordingly to the forces applied by the charged balloon. If the balloon is negatively charged, the electrons in the material are repelled, and the closer to the balloon is slightly poor to electrons and is slightly positive charge, although the total net charge is still 0. And so the result is that the electrical force will attract the balloon and the section of the material nearest to it. Both salt and pepper grains are attracted to the balloon, and the closer the balloon gets to the grain, the more strongly they attract to each other. The force of gravity also plays a part in determining which grains stick to the balloon and which stays on the plate. The mass of the pepper grain is smaller than the salt grains, and so they're lighter and more likely to be attracted to the balloon at a larger distance. However, at a smaller distance, the electronic force may be bigger, so it could also attract the salt grains. And if we want to get a good separation and only get the pepper, we would have to find the exact distance to between the balloon and the plate to where only the pepper sticks and none of the salt. And so with my results, by providing both salt and pepper, both have a physical property that interact with the static electricity from the balloon, and by rubbing the balloon against my head creates a friction force and a static electricity. The charge pushes the electron to the back of the pepper particle and then attracts from side to which a positive charge.